Hi everyone, welcome back to Pre-Cal 40S. We're going to continue on with 3.3 from the textbook. It's R11, and in this video we're going to look at the integral zero theorem. So if we were to look at this following expression here, where we have x minus 1, x plus 2, x minus 5, they're all factors, multiply them together, we end up with x cubed minus 4x squared minus 3x plus 10. I want you to note that the factors of the polynomial are x minus 1, x plus 2, and x minus 5. The zeros of the polynomial are 1, negative 2, and 5. So the zeros are opposite to the connecting sign that are in here. Okay, now particularly have a look at this here, this plus 10. All right, so when we take and we multiply all the factors, the constant is plus 10, which means that only the factors of 10 can be factors of the polynomial. This is known as the integral zero theorem. So if we just look at this example right here, if we take negative 1, positive 2, and negative 5, and we multiply those together, so if we have negative 1 times 2 times negative 5, we end up getting plus 10. So I want you to think why that happens. I want you to think, well, this is the y-intercept, and what is the value of x at the y-intercept? Well, the value of x is 0 at the y-intercept. So this is why when you just take these numbers here, you multiply them together, it's as if you're treating x to equal 0, and you end up getting 10. Or the y-intercept, in other words. So this leads us to figure out an easier way, or kind of narrow down a number of opportunities where we can find possible factors of the following polynomial. Because really, how do we know what numbers to choose, where to start, where to end? Okay. So for this, what we're going to do is we're going to look at the 8, and we're going to take all the factors of plus 8, which is plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Those are the only values that we could possibly take and figure out whether or not they are factors. No other numbers are going to work at all. All right? So that's going to help us with our strategy when we're asked to completely factor any given polynomial. So first what we're going to do is we're going to use this, and we're going to pick one of these values and see which ones make f of x equal to 0. So we're going to start with, let's start with f of 1, and let's figure that out. So that's going to give me 1 cubed minus 3 times 1 squared, minus 6 times 1 plus 8. And we want to see what that equals. Well, we get 1 minus 3 minus 6 plus 8, and that actually gives us 0. So, since f of 1 is equal to 0, we know that x minus 1 is a factor of my given polynomial. So from here, I can do synthetic division and figure out what the rest of them are. I could continue on and guessing and checking these values here if I wanted to, but it might be a while. I don't know. I'm kind of taking a risk doing so. So another strategy is from there, once you have one of the factors, you can do synthetic division to figure out the rest. Okay, so if you recall how to set up synthetic division, you write down your 1 there from here, and the coefficients of your polynomial, so 1 minus 3 minus 6 and 8. Then I'm going to pull this 1 down, 1, take that, multiply, 1, add as I go down, and multiply this and this. I should get my fingers out of the way. Multiply that and add down. Multiply this with this and put that there and add down. Now, because I have a 0 here, that means that x minus 1 is for sure a factor, okay? So far what I have is, when I factor out the x minus 1 from my original, which is way up here. So when I factor that out, this is what I'm left with. I'm left with x squared, that's the x term, and that's the constant. Okay, so this is where I'm going to get this polynomial from. And if you notice, this is much easier to factor. So I can just use simple factoring to factor this out. Okay, and now I can say that f of x is equal to x minus 1, and this factored out is going to be x minus 4, x plus 2. Okay, so this is completely factored. All right. Okay. Now, just a little aside and just kind of a little reminder. If I were to look at the remainder theorem, what does the remainder theorem do? The remainder theorem tells us the remainder when dividing by a specific value x minus a. All right. Now, if that value ends up being 0, then we know that it's a factor. So then we call that the factor theorem. Okay. So it tells us that x minus a is a factor when f of a is equal to 0. All right. So this next example is pretty much the same except for one difference. So if we look here, the coefficient in front of the leading term is not 1. It's something other than that. It's actually a minus 2. So what we do in this case is we take this minus 12 and we use the factors of the minus 12, and then we take the negative 2 and we divide each of these factors by negative 2. So I'll show you what I mean. So if I have plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12, because I have this minus 2 here, I'm going to take each one of these and I'm going to divide them by 2. Okay? And so these are what my possible factors are now. So in order, my list, let's just rewrite our list now so it looks a little nicer with everything kind of reduced. We're going to have plus minus a half, plus minus 1, plus minus 3 over 2, plus minus 2, plus minus 3, and plus minus 6. So these are now all of the possible zeros for this function here. Okay, so what I'd like you to do is I'd like you to hit pause and I'd like you to try and figure out, I want you to try, let's try x equals 1. And I want you to try x equals 1 and see whether or not it is a factor, and then go to the next step. So press pause and then come back and see what the answer is to this question. Okay, so now that you're back, Hopefully you've actually tried this question. We're going to look at this here. I told you to try x minus 1 and determine whether or not it's a factor. So when we plug it into our f of x, we end up getting that it is not a factor. It is not equal to 0. So I'm pretty much at the point where I'm pretty 100% sure that it's not going to be equal to 0. I can just say it's not equal to 0 and then move on. I don't need to actually figure out the value. This one here, so I'm going to move on and I'm going to try x equals negative 1. So when I try x equals negative 1, I'm going to also find that it is not equal to 0. So I'm going to move on to 2. So let's try x equals 2. Once you've tried x equals 2, well, we see that it does equal 0. Therefore, we have determined that x minus 2 is a factor, okay? So we're going to look further and we're going to use x equals 2 to divide. And we're going to use synthetic division. So this is what my synthetic division setup looks like. Okay, and when I go through and do the division, I note that my remainder is equal to 0. So this gives me my x squared term, my x term, and my constant. Okay, I can write my what I've got so far as my factoring. So far this is what I have for f of x. I've got x minus 2 multiplied by negative 2x squared minus x plus 6. Now I need to go through and I need to factor this, factor the second bracket. So by doing so, I see that I now have f of x is equal to x minus 2 times negative 1 times 2x minus 3 x plus 2. Okay, so I'm going to rearrange that to write the negative 1 out in front so I can just kind of clean it up a little. So I've got f of x equals negative x minus 2, 2x minus 3, and x plus 2. So if I look at this here now that I've written it, and if I set all of these brackets equal to 0 and I solve for x in each case, for this one here I get x equals 2. This one here I get x equals 3 over 2, and here I get x equals negative 2. So if we look at the factors that we have, if you notice in the above list, these all appeared in that initial list that we started off when we were guessing all the possible zeros that this polynomial could have. Okay, so these all appear in the list above. So just kind of as a little note. All right, so I have one more example here, and what I'm going to do for this one is I'm going to get you guys to try this on your own and bring it to class, okay? And we'll have a look at it and discuss it next day. All right, take care. Have fun. Bye.